when we do math during an experiment or at the end of experiment, we have to make sure that we take significant figures into account, okay? So there's two sets of rules that we're going to go over. The first set of rules has to deal with when you add and subtract numbers, okay? So when we add and subtract numbers, we do the math, then we round our answer to the fewest number of decimal places involved. You round your answer to the fewest number of decimal places involved. Okay, we round our answer to the fewest number of decimal places. So this, when we add and subtract, we're really not thinking about significant figures. We're thinking about decimal places. And so when I say decimal places, what does that mean? It means digits after what? Digits after the decimal point. So if I just look at this number right here, 3.16, how many decimal places does that number have? 2. 1, 2. 3.165, how many decimal places does that number have? 1, 2, 3. Decimal places are numbers after the decimal. What about this number here? Does it have any decimal places? No, this would be a whole number, right? So the fewest number of decimal places present here would be 0. Okay, that means our answer would have to go to a whole number. So let's do a practice one here. Okay, it says that I've got an example that's 12.520 plus 14.0. Okay, this number right here is just the raw answer before we do any rounding, before we take significant figures into account, okay? So let's look at this. If our rules for adding and subtracting are looking at the fewest number of decimal places, tell me how many decimal places does our first number have? 3. And how many decimal places does my second number have? 1. So how many decimal places can my answer have? Only 1, right? The fewest number involved. So this one is my least precise measurement. So my answer only gets to have 1 decimal place. So where should I round my answer to make it correct? 26.5, and that's it. Okay, that's it. We just round our answer to have the correct number of decimal places. Now, the reason we do this is because we cannot have our answers, our final products, be more precise than one of our original measurements, right? My original measurements were 12.520, which is really, really precise, and then 14.0, which is less precise. So I cannot have my answer be more exact than one of my measurements. Okay, does that kind of make sense, how I chose that? Okay, let's try an extra practice one here. I'm going to put one more of those up before we move on to the next rule. Okay, do you have your calculators out? Please go ahead and grab your calculators if you have them. Okay, I'm going to do another example here. 6.49 plus 12.1 plus 8. We want to go ahead and add that just like normal. I want you to just add it up and write down just the raw answer for right now before we do any rounding. Okay, so 6.49 plus 12.1 plus 8 gives me 26.59. Would we agree with that answer just after we did the addition? Okay, so now if I have to round my answer to the least precise or the fewest number of decimal places, let's examine our numbers here. How many decimal places does this one have? 2. How many decimal places does this one have? And how many decimal places does that have? None. So how many decimal places does my answer get? None. So is my answer just going to be 26? No, what should it be? 27. Very good. You guys are pros, okay? We round it to our decimal places. Okay, we feel okay about that? Okay, so now let's move into our rules for multiplication and division. When we multiply or divide, we do the math, then we round our answer to the fewest number of sig figs involved. So not decimal places, but you have to count your sig figs now. Okay, so we round our answer to have the fewest number of sig figs that we started with. All right. So what that looks like, I've got an example problem here listed, 2.40 times 12. And the raw answer without any rounding is 28.8. But if our rule says we have to round it to the fewest number of significant figures, let's figure out how many sig figs does my first measurement have? 1, 2, 3. And my second measurement has only 2. So my answer only gets to have 2 significant figures. So what could my possible answer be? 29. Another possibility would be to say 2.9 times 10 to the first, right? I could put it into scientific notation. Do I have to necessarily put it in scientific notation there? Not necessarily. Okay? Okay, do we have questions about our rules for significant figures? Okay, I'm going to go ahead.